Welcome to Code Design. Today we'll be discussing Leetcode 733 flat fill. So let's look at the problem first. So you are given an image represented by an MN grid of integers image where image ij represents the pixel value of the image. You are also given three integers source, source row, source column, and color. Your task is perform a flat fill of the image starting from the pixel image SRSC. So let's look at the diagram. Here we have a matrix and source color is for this pixel 1. For all of them is 1. Here is color 0. Here is color 0. And what we have to make in the first problem, we have to make color 2. So for the adjacent matrix and starting from here. So this is red just to point out, but its color itself is blue like other colors. So if we start from here, one adjacent cells, right? We have adjacent this one, this one, this one, this one. But these two has blue. Since these two has blue, we can color them. What is our color? Color 2, right? From 1 to 2, we can do it 2. And for these things, they are not the same color, so they will not be touched. And then for this one, right, when we get this one, we get a adjacent cell which is also the same color. So we go here and we try to go here and here, but this is out of bounds, so we cannot go out of the matrix. And for this one also, when we go there, we find this one, and rest is out of bounds. For this, we cannot go here. And for the same here, from here we can go only here. So we change all of the color to 2, and there is no way, because it doesn't work diagonally, only adjacent is horizontally or vertically, so we cannot go here, and it will be untouched 1. So this is our task. So what we can see here, we can see that for starting from this cell, we can go to the adjacent cells, whatever is adjacent from there, and from each of the adjacent cells, we can go their adjacent cells. So if we see the requirement is actually go with a depth first search or breadth first search um, type of thing. So we can actually process one and then process all the connected cells with this one. So we can solve this different way, DFS recursive or BFS using a queue, or we can solve this iterative approach of DFS if you don't want for larger arrays to have a stack overflow. Okay, so we create a helper function, void flat fill helper, which is our DFS. Image source row, source column, and we pass the source column here, source color here, and also target color. So in this function, we first check if whatever is our source row and source column provided is within the bounds of this matrix. So what is our boundary? For row, source row, if it is less than 0, or source row greater or equals image.length, then it is invalid, right? Or our source column, if it is less than 0, or source column getter equals image 0, which is for the first row dot length. First row dot length means basically the column length. And so the source column, if less than 0 or getter equals the column length, it will be invalid. And whatever is our source color, if our image of SR SC not equals source color. So if whatever is our current cell, if it is not the same color as the source color, whatever is our source, then we skip, right? Here we skipped this 0, because they are different color, not same as source color. And what if our image SR SC equals our target color? So say we want to visit this one, and this one is already 2. If this one is already 2, already in the same color is our target color, then it's not actually source color. So we are not going to visit it. And if it is already target color, like if we have a input array like this, then it's already if we are given the source row here, so we don't have to do anything because the matrix is already filled with the color. And we have an example like that. So one of the example is all 0. So output is 0 because the target color is also 0. So it's already um, all the source has the target color. So this is our bounds and condition to exit from the DFS. So we'll simply return. And what we'll do now, image SR source row source column equals target color, right? We assign the target color, or another way we can say on DFS perspective, we mark this cell as visited, because we need to keep track on a DFS if it is visited, right? Because these metrics, otherwise we'll keep um, roaming around these cells. It will never end if we don't mark it as visited or update the color to target color. Once we do that, we check the boundaries, and then we visit a cell, update its color to target color. Then we need to find out all the cells connected to it, right? So if this is my cell, I need to call DFS, the same procedure for this one, this one, this one, this one. But for these two, it's not same as the color of this one. So when we call it, it will just return. So similar, we at one time we could be in even in this cell, and from this cell, like this cell one, then we need to visit this one, and we cannot go here or left or right, right? So let's call it. We need to call this flat fill helper with image source, source row, source column, and source color, target color. So if this is my cell, this cell would be row -1 because row is increasing here. It starting from here. If we consider starting from here, then row is increasing going down, and going up row is decreasing. And column, if we consider starting from here, going right, column value will increase, and left column value will be decreased. So this is one of the case. Okay, the next what we can do, instead of going up, we can go down. Down means row will be increasing. And then we can, and column is fixed for these first two, right? Because we are going up and down within the same column. That's why I didn't touch SC. So column is fixed. Now we'll keep row fixed, and for column, I will do -1 and +1. So -1 is going left from here, 1 it is going here, and for +1 it is going right. If it is here, it is going right is here. And so that's it. It's a void. We don't need to return anything. Calling this one, this GFS will end when this bound and this condition, right? When the color doesn't match. Now let's call this function from here, DFS. But so what we need to pass? We need to pass the source color. So what is our source color? The starting column, the starting cell with the given source row and source column. This is actually our source color, and this color is our target color. So if source color not equals color, if it is not our target color, if it is already target color, that means we just return image. So the cell that we start with, if is already our target color, then we don't need to do anything. So if source color not equals our target color, then we call this function flat fill helper. We pass the image, source, source column, source row, source column, source color, and this color is our target color. So let's run this. Okay, line 15. Oh, okay, let's submit it. It got accepted, and it beats 100% of the all submission, and memory is also efficient. We are not using any extra memory here. So time space complexity. Time complexity is O of m n. M is number of row and n is number of column. So for DFS, we need to visit at best all the, at worst case we need to visit all the cells. And what is space complexity? Here, if you see that we are not using any additional space to store the status, like we are changing the color here, right? We are changing the target color, but we are using the same image matrix, same image array. But there is a DFS call, and for the DFS call, if you see that each of the cells will be calling, at best we need to call DFS from here to here and here. So this is how, if we can end up to traversing m by the whole matrix. So these many recursive call could be there. So space complexity is also O mn.